Right. First topic is atoms and periodic table. This one is a relatively easy one. It's very straightforward. With the mass and isotopes topic, you need to know the definitions by heart. So you need to know all of these definitions. You just need to know them, and you need to know them word for word. The atomic number. So usually you're given like a number on the periodic table, like for example, Na, and you're getting a number on top and on the bottom. The bottom number is the atomic number, and that's the number of protons in an atom. If it's just a basic element, the number of protons are going to be the same as the number of electrons. So you can think about the atomic number being the number of protons and also the number of electrons. The mass number is the sum of protons and neutrons in the nucleus of an atom. So it's going to be the top number you see usually when you have the element, the top number. And that's the total number of neutrons, the total number of protons. Isotopes, they are the isotopes of an element of an atom, basically. They have a different number of neutrons, but the same number of protons. So I could have sodium isotopes where they have the same atomic number and a different mass number because they have different number of neutrons, but the same number of protons. So it could be sodium, like, I don't remember which sodium is 12. I don't know. Let's say it's 12. They're both 12 atomic number, and it could be like 30 mass number and 31 mass number. These are isotopes. Same element, same number of protons, different number of neutrons. So same atomic number, different mass number. Relative atomic mass, AR. This one, I cannot emphasize this enough. They ask this maybe once every year, once every 2 years in the exam for the definition. I don't know if it's your year, but it's important to note. The relative atomic mass definition, word for word memorized, is the element is the weighted average mass of all the isotopes of an element compared to 1/12 of the mass of a carbon-12 atom. That is, I cannot expand more than you just need to memorize the definition of it. You also have to be able to calculate the relative atomic mass through different isotopes. You have the equation right there. It's the sum of the mass of each isotopes times the abundance divided by 100. So if there's like 60% of 30 and 40% of 28, you're going to do 60 times, I already forget the numbers, but 60 times 30 plus 40 times 30 divided by 100. I don't remember the numbers I gave, but that is the equation you need to use. Ions are particles with an electric charge. So they don't have the same numbers of protons and electrons. So remember when I said elements with atomic number, they have the same number of protons and electrons. In ions, this is not the case. In positive ions, or some people like to say cations, they have more protons than electrons. And negative ions is the opposite. They have more electrons than protons. And they do this, they form these ions by gaining or losing electrons. So positive ions, they're going to be losing an electron. They'll lose an electron, making them positive because electrons itself are negative. So with losing an electron, they're going to become positive. Negative ions, they're gaining an electron. That makes them more negative. So negative ions, cations and anions. The way I memorize it with positive ions, cations are positive, like cat's paw, positive. That's the best way I can explain it and the best way I memorized it. That's how my teacher taught me. Cations are positive, anions are negative. This is all pretty just general content, straightforward content. I'm hoping that was clear. Okay, now here's a question. I'm going to give you guys about 2 to 3 minutes. I'm going to give you guys like maybe 2 minutes to do this question. They should all this. So there's a bunch of math and as well and just definitions. So just have a look at it, have a go at it. Okay, let's have a look at this question. First thing, it's asking you to define the meaning of isotopes. That one should just be the same number of protons, different number of neutrons. That one is already, it's a straightforward 2 marks. You're just defining the term. Second question, I'm hoping everyone did do this question, but it's just the math. So using the equation, it's just 69 times 60 plus 71 times 40 divided by 100. And that should give you the answer. And remember, it says give your answer to 1 decimal place. So be very, very careful with that. The answer you should have gone should be 69.8. The third question, give the number of electrons and neutrons in an atom of the isotope gallium 69 and 31. So this is what I meant with the number on top and number on the bottom. Bottom number is atomic number. Top number is mass number. It's asking you for the number of electrons. We already know that atomic number is the number of protons. And I've also said the number of protons are the same with the number of electrons when it's just the atom itself. So the number of electrons is simply 31. Now we need to figure out the number of neutrons. We have 69 as a mass number, and 69 is the number of protons and neutrons. We know that the number of protons is 31. So to figure out the number of neutrons, we simply just do 69 times 31, which should give you 38. That's the number of neutrons. To figure out the most likely formula of gallium, the way that I do this is kind of a little bit cheat trick, but I think it works and it really is helpful. It's by looking at the periodic table and looking at the column that is in, what group it's in. If it's group 1, the ion it's going to form is going to be +1. Group 2, +2. Group 3, +3. 4, we don't really look at really. Group 5, -3. Group 6, -2. Group 7, -1. So gallium, if you look at the periodic table, is in group 3. So I instantly say, okay, that likely formula for the gallium ion is probably going to be gallium 3+. That is the trick that I use. I think it's a really good cheat trick and it's really easy if they ask you for an ion. Just look at the group, and the group that it's in is going to be the most likely ion it's going to form. So here are the answers for this question. Should be pretty straightforward, but let me just see. When drawing ions, can you just draw the outer shell? No. I don't think so. I think you have to draw all of them. I think you do have to draw all of the circles and all of the electrons with, I believe that has to be, I think you do have to draw every single shell. Better to be safe than sorry anyway. But I do think you do have to draw all of them. Yeah.